All right, in this debate, I'm going to point out how the sun angles in Sydney and Australia and other places don't work, and the globe model is not as perfect as people think it is. And this is the subterfuge, the magnetic declination. It's like a fix-all, if you will. So it says magnetic declination or variation is the angle on the horizontal plane. Between magnetic north, the direction the north end of the magnetized compass needle points, corresponding to the direction of the Earth's magnetic field lines, and true north, the direction along a meridian toward the geographic North Pole. This angle varies depending on position on the Earth's surface and changes over time. Of course it does. So it has to be done on a horizontal plane, and or it doesn't work. I'm going to show you that later on in this presentation. But the first person to discover it, they say, was James Clark Ross back in 1831, where it was 70 degrees north and 96 west, which is insane. And then 70 years later, almost, um, Amundsen in 1904 measured it at 70 north, 96 west. It barely moved a couple miles in 70 years, and then all of a sudden it just jumps up. But whatever. Um, so they have the geomagnetic pole and the south geomagnetic pole, and then they have the magnetic pole, north and south magnetic pole. So currently we're at 86 north and 164 east, and so there's three poles. You have the geographic north, the magnetic north, and the geomagnetic north, and they all have their own purposes. So they don't even line up with each other. But so you wonder what's the geomagnetic poles for? And because they're at 80.8 north and 72.7 west. That's a long way off. And that's in Ellesmere, Canada. And that's where people think the magnetic pole is, but it's not. That's what it says. What is the geomagnetic poles used for? It's a center of open magnetic field lines which connect to the interplanetary magnetic field and provide a direct route for the solar winds to reach the ionosphere. Yeah, it's the model they show you with the perfectly centered magnet in the center of Earth. It's just a bunch of BS. It's for their make their planets work. It's not has nothing to do with reality. So geomagnetic pole versus magnetic pole. The magnetic poles are the actual poles of the Earth's magnetic field, but are not antipodal, as they do not pass through the Earth's center. So for all the people who said just look at the South Pole and you could figure out the declination, that's wrong. They're not antipodal. It changes as it goes around on a globe. It's a jumbled up mess, but it's a fix all, like I said, and it's going to become pretty apparent. So I was looking at the declination. I was like, how many poles are there? And I looked it up, and it says two dominant magnetic poles and several weak quadrupoles, of which there are at least mathematically about eight in number. So there's all kinds of poles. They have to do this to make their model work. They have to turn and twist shit all over oblivion. So here's where it shows that everybody refers to the northern hemisphere magnetic north. Okay, so do pilots fly magnetic or true north? Since the beginning of flight, pilots have been using the magnetic compass for navigation. It doesn't matter if you're flying a Piper Club or a Boeing 747. You'll find a compass in the cockpits of any aircraft. So this is real. How do we get to places? How do we fly? How do we know where we're facing or where we're heading? A compass. Or you could refer to a model, but you can't use that model to prove a model. That's what they do, and that's wrong. So look here, it says the following methods require that you have a general idea of your position. So if you don't know where you're at, you can't even use magnetic declination. So GPS receivers have internal data which aligns with the declination. So it's already in the GPS receiver. It's in the SunCalc data. So you could take your map and line it up with a known landmark to figure it out. But it says, look, it says here that the Polaris has a almost a 1 degree radius around the north celestial pole. So that allows up to 1.5 degrees of. So you go to look up what's the magnetic declination. So I looked at Perth. It says plus 14.62, and that didn't line up. So I check another place and it says 14.62, but then it says it's close to zero on the same page. So then I check my location. It says -6 degrees in Jacksonville, Florida. I kept looking and it said 0 degrees or almost 0 degrees in another place. Anyway, Mitchell from Australia goes to check the due east sunrise on equinox there right outside of Sydney, and SunCalc pegged it. It was perfect. But what they didn't tell you is that declination is included in all the calculations. They don't, but it certainly didn't line up with the compass. So let's take a look.
Candles Beach. Hope everyone can see that. It says Candles Beach right there. Put it over to the camera. Alright, so zoom in here. I've got the park bench. Zoom right in, park bench, the shower, and I'm right there, in between. Correct, but as I'm going to show you afterwards, using my compass, the only true direction that we can ever achieve magnetic north, from magnetic north, that sun right there is not rising 90 degrees east. There it is, right there. And exactly where I thought it was going to be. Beautiful. That's right, it does not line up. Those rocks out there, those rocks right here do not line up with 90 degrees on my compass. And that is the only thing that we can use to get a true reading. And I measured with my compass, the only thing that can measure an absolute direction. I measured 81 degrees to the point where the sun rose, those rocks right there. 91 degrees is over here. I would not see this sunrise from this position if it actually rose 91 degrees.
So speaking of other people, they said just check your sun at high noon. But if it's, here it is, 5:45 in Sydney, and it's gonna, if it goes 15 degrees an hour, it's gonna line up 6 hours later north. So that is not going to tell you where your true north is. Anybody who tells you that is not thinking. I mean, basically they're saying that if you have magnetic declination that's off, then your sunrise and sunset's going to vary wildly. And you see here, it just goes on a 12-hour day. And so the time of day would have to vary too. Look, this is for Australia. See how all these continents, it shows them flaring out. And so here's another, they have to spread the map. They're spreading a flat map. So this is east, or this is to the right of the Bering Strait. And it's all east declination. Then you cross the Bering Strait and you go down and it's to the left. So there's a zero line right there, and they just basically spread it out. Is all they're doing. And I mean, if you look at the magnetic declination maps, it's pretty obvious. They're just spreading everything out. So here's due east. This is due east with no magnetic declination. You see the angle when I zoom in. It's going to be 90 degrees to the meridians. And so this is about 12 degrees underneath. Does that look like a 11 degree angle? No, so you have to use a flat plane. That's more than 11 degrees. It's like 25 degrees. And that's basically from Sydney. Now here, so what I do here is I'm showing you 86 north, 164 east. That's the magnetic North Pole. So I'm going to trace it down to Sydney. It's a straight shot. Look, that's where the magnetic North Pole is. There should be no declination if that's what we're going off of, because look here. All the way down to Sydney, it's a straight line. So why would there be any declination? Watch as I back out. It follows right along the meridian. They must be talking about geographic or interplanetary North Pole. They just confuse us. Look, that might be off a degree, if that. It's insane. So next I'm going to check the South Pole. And I'm wondering, why do the Southern Hemisphere continents not use the South Pole for declination? But look, so there's the South Pole over about 30 degrees off that way. So you're not going to use the South Pole to get your declination in the south. And you can't see Polaris. And the sunrise, I mean, look at 90. Here I draw 90. And the yellow line is the due east. And there's the 90 from the South Pole. So think about this. If you're going to make a map to start with, and you have nothing but a blank canvas and a compass, so what are you going to do? You're going to draw it out, basically, or you're going to put together a bunch of local maps and you're going to go by the compass reading. But if you already have a model, you're going to have to make adjustments to make it all fit into your model, and that's what they do with magnetic declination.